room. Please sit. So this is the agenda page from Data Tracker, and it's getting better and better and better. So we'll be actually using it as the starting page for what we'll be presenting to you. So if you're looking for the presentation, the Etherpad, etc., we'll show you as we do it where the links are, so you can participate to what we're doing here. So all the material we'll be showing is on this button here. It's also available on the cool applications that you can download from your preferred store on the web. But this is really a cool place to get it. You've got all those two links here. Will give you all the documents we'll be talking about today in PDF forms, all the workgroup documents and personal submissions. And last but not least, here on this button here, you will get the link to the Etherpad. Clicking it. So please participate to the Etherpad. This is where we are taking our minutes. This is also a very useful page if you did not get everything that was being said. If you want to reread later, please just open this window. If you think that the minutes were not taken properly, in particular for what you just said, please go ahead and modify the text live on the Etherpad. That's a very, very useful tool for all of us in this room. And with this, since we're a few minutes past the hour, oh, I see that people are going on the left. I would strongly encourage you to try sitting on the right, not using my right. I'm always right. So please pick that one, because you'll see better. And then when you come to the mic, and if we ask to raise hands, we don't see people on the other side here. We've been suffering from this on previous meetings. Okay, and with this, let us start with the agenda bashing and all the nice things that we're used to doing. So this is the LP1 working group, co-chairs Alexander and myself. And we've got a brand new Notwell at this IETF. So if you're not used to the Notwell, if you've not read the previous RFCs, which provide the policies for the IETF, this is a nice occasion to go ahead and read them because they are brand new and shining. Basically, what this will be telling you is that if you're aware of IPR on anything that's being discussed in this meeting, since this is part of the IETF activity, you are supposed to disclose this IPR, whether it's your IPR or somebody else's IPR. And if you don't want to disclose it during this meeting on the mic, then you can always talk to the chairs later or send us an email. This is an IETF meeting. Minutes will be taken, hopefully by many, many people using the fine Etherpad link that I just showed you. The meeting is propagated on Meetico. You can join the Meetico from this room or from anywhere else. And I'm giving again the pointer to the Etherpad. We'll be distributing the blue sheets in a few minutes. We are used to seeing people come late, and I don't see that today is an exception to the rule. So we just delay so we don't have multiple ways of blue sheets. Yes, it's just the next. So we are looking for minute takers. So do we have volunteers? I see Dominique, Evalio. So that's kind of cool. Do we have somebody for Jabber, Meetico? Diego, so fine. Okay, so we are just doing great. So I just showed you where I'm picking the meeting material live, so I'll be going back to that page, and that's a cool place to get it. So here's our agenda. We have 2 pages agenda. It's quite full, but we should be okay. So we'll be Dominique will be presenting us the news from the hackathon. So there were incredible stuff which were done at the hackathon, and we are glad to show that. Then we'll talk about the results of the workgroup last call on the overview document, and Stephen is there with us to present this. Then there is 2 sets of slides for one, or actually 2 documents, but the set of slides don't really match documents. So we'll be talking about the static header compression document, which has a fragmentation part, and that will be presenting to us by Carlos. And then Anna and Laurent will be talking about the chic compression. And that SHIC compression actually spreads 2 documents right now, the SHIC for IPv6 and UDP, and then the CoAP piece. And maybe we'll discuss at some point if we need to reorganize that a little bit, because the CoAP document has grown smaller and smaller. And then Diego will introduce to us a new work, which is extending the SHIC to ICMP. We'll have a little bit of time for Yang for SHIC, and Laurent will be showing that to us. And then we'll have quite some time to discuss the rechartering. We left the last 5-10 minutes for news from IEEE by Bob. Bob, if you can hear us. So I was at the IEEE last week as well. There are 2 interesting pieces, 2 pieces which are of direct interest for us. There is the IGLP1, which basically met every day last week, and there is the 154K effort, which is also an IEEE designed LP1 technology. And so I hope Bob focuses on those, but he will give us news from the IEEE. I would strongly encourage, and I see that Juan Carlos is with us, to extend this idea of giving us like a short news from the world about things which are happening in other bodies like LTN. So if you could think in further meeting to come and present like 2, 3, 5 minutes on what has been happening in the last quarter in LTN, LoRaWAN, or NB-IoT, any of those, a small slot would be very good, so that we get news from the world. So this time it's going to be IEEE. And with that, I'll fly to the airport because I'll be late. You want to start there?
Yep, sure. So this is a short refresher of our charter and our milestones. So we were formed in almost less than a year ago with 2 main charter items. So we have the baseline technology description and overview document, and we'll be talking about this in the beginning of this meeting, and then the technology drafts, and then the drafts that are actually dealing with the compression and the fragmentation. So in our compared to our milestones, so we have most of them are we got them on time. We're with slight delay on the others, so the LP1 overview document and the compression and fragmentation mechanism, but we're pretty well on them, and right now you'll see why. So we had from the start a very ambitious, challenging, very challenging charter, and basically, we have to deliver everything in less than a year. We're actually pretty happy with the development of and with our advancement. So we had a design team that met and that really accelerated the things. And before the last IETF, everything. Most of the stuff were cleared out, and since then all the work has been happening on the mailing list, and it's very open. So here is the deadlines that we had initially. So with the overview document ready by April, then the SHIC for IP-UDP by May, and CoAP by June. So I would like to have a special thanks to the group and to everyone that has participated, because we had a very active work during the past 3 months. So we had 6 interim meetings, and I would really like to thank everyone. So people did marvelous work. So we could advance really rapidly. There were a lot of things that were done. So the LP1 overview document, we started a working group last call in June, and since then there were a couple of minor commands where they have been addressed, and we'll see. We'll have the presentation from Stephen that will give us the results of this, and we will be closing the last call very soon. The SHIC IP-UDP document is advancing really well, and in the very near future we'll go for. We think that we'll go for last call, working group last call, and I hope to have more news from Carles and from Anna on this point. So that's where we are with our charter and with our action points. And I'd like to give you just 1 minute overview of a report of a meeting that happened yesterday. That's called the Yang of Things. And this meeting actually is the place where the constrained world meets the management world. So it was a side meeting. The room was full, a lot of interesting discussions, and the takeaway for this is actually that for the next IETF we'll have working implementation, and we'll have all that is necessary for the COMI protocol. And as you know, the COMI protocol is the one that we may be using for configuring the compression contexts. So that's a thing that will come. Right now we have the compression mechanism, but we need a way to configure the contexts. So it is a work to look for, and I think it will be that we are right on time and we have all that is necessary. So with this, Pascal, we should.
So with this, we'll move to the first presentation for this meeting. And our first presentation is the LPWAN overview. So let's see where we are with the LPWAN overview. So we're done. We have completed last call on July 4. We're done for this working group, not for the IETF, but we've completed the working group last call on the 4th of July. So the document is now officially independent. And Alexander Peloff here will be the shepherd, and we are now fixing the review commands, and the document for I know is pretty much ready, minus a typo or two, but we are there. So we'll do the shepherd write-up and ship this document real soon now. That's where we are. And so, Stephen, if you will. Oh, there was the hackathon.
Oh, that's.
Oh, yeah. Okay, I'm sorry. It's Dominic first in the agenda. So, Dominic, if you will.
While Dominic is coming up, I just can you just submit a update to the milestones so I can approve them? So just to keep the times update.
Yeah, thanks. That was actually a question. We'd like to have the milestones up to date. So we'll submit.
Dara Suresh.
Yeah.
Going back to the agenda for a second, because I don't think
I have the agenda.
Okay.
Sure. So first is the hackathon. Okay, so before actually discussing the LPWAN overview document, we have so there was a hackathon that was organized, and Dominic is kind enough to present us all the things that were achieved.
Okay, good morning. So at the hackathon just before this IETF week, we had an activity on Check, and it was actually two activities going on. One was an interop testing between various implementations, and the other one was actual hacking, improving what we already had. So the companies or entities represented are listed here. Okay, I can do it myself, apparently, yes. So before the hackathon, the teams that came had the following assets. IEMT Atlantic, previously known as Telecom Bretagne in France, had an end device implementation of SHIC in Python and a network side implementation in JavaScript and rules set up for LoRa transmission. Aclio came with an end device and network implementation in Go on LoRaWAN and Sigfox. And myself from Orange, I came with a LoRa device, legacy device that knew nothing about IP, but was able to transmit frames on LoRa. The interop mostly happened on Saturday, and then had the IEMT Atlantic and Aclio face each other with their opposite implementations and device versus network in both sites, and the results will be shown at the last slide. And so that was the interop part of it, and then the hacking part of that was IEMT Atlantic adding the rules and testing on Sigfox network on their own end device and network implementation, and myself ripping some Python code from IEMT Atlantic end device side, put it on the network side, and write a quick decompressor that would be able to invent CoAP UDP IPv6 messages based on legacy frames being transmitted by my LoRaWAN device. And so the lessons learned from this hackathon, so we have shown that we have multiple technologies interoperating. We discussed and clarified how we want to do padding, because when the header is compressed, it does not necessarily fall on a byte boundary. So there's padding that's involved on technologies that are byte oriented. And so you could have padding between the compressed header and the data, or padding after concatenating the compressed header and data. And in some cases, you would have two paddings. And so the decision was made to put padding at the very end. Also, we agreed on a temporary representation for rules, because the rules have to be agreed on between the two parties. And so right now we use a JSON representation that is not meant to become the standard, but at least for the interop we had to agree on something. So that was agreed. One issue that was discovered is how to manage the variable fields that happen to have 0 length. And CoAP, in a content, has an interpretation of 0 length as representing a 0 value. And Sheik wants to be able to apply 0 length fields to non-existent fields, so that we can reuse the same rule number for frames which have some fields present and some non-present. So here we had discussion on how to interpret that, and one has to agree on how this works on CoAP, especially because of this 0 length interpretation in CoAP for contents. And eventually, IEMT Atlantic provides its implementation open source on GitHub. So this can be used as a reference point for anybody wanting to implement that. And I think I'm done.
Oh, that's fantastic, Dominique. I have a question for the authors. So you raised a number of points. I think for each of these points, we should open a ticket, because we've got a workgroup document. So I can help opening the tickets if you send me an email with the prime statement of, and this should be individual threads on the mailing list. Then we resolve this thread, and I'm pretty sure that we are ready for last call. So let's open the tickets, if you don't mind. Send me an email, and let's start from there.
The issue on Laurent Toutain, the issue on 0 length is just for CoAP. So for IPv6 UDP, there is no problem.
Yes. So part of the discussions today will be if we merge the CoAP document or not, and depending on that. Well, unless the solution for CoAP makes it so that we have to change the IP UDP, right? So I would like to see this sorted. Any question in the room? Okay. So 2 implementations, 1 open source, that's a dream.
Okay, thank you. So right now we actually move to the LPWAN overview from Stephen. So let's bring up the agenda.
So that's good timing. So I just posted 06.
Oh. Okay.
Like about 2 minutes ago.
Okay, that's fantastic. So it happens that we have uploaded your slides, but they're not yet on the website, so I will have to take them from my desk. But don't worry, they are on the IETF site. You'll be able to see them very, very, very quickly.
Yeah, so I got some updated XML minor editorial changes, basically, from Charlie Perkins last at 2:30 a.m. and at 7 a.m.
I read it at 6, confirmed I was happy with them at 6:30. So that's how we are.
Sometimes I'm out of bed at 2:30, but not at 7.
So.
Yeah, so that's what I said. Okay, so there's not much to say here, but there we go. Next.
Well, oh, you don't have the. Okay, next.
Oh, okay, I have it. Yeah. Okay, so so between 4 and 5, there was just basically minor text tweaks, mostly. Yeah, it was just minor editorials. But from 05 to 06, it had. I got the text from Charlie, which posted 06 there like a couple of minutes ago. Have a look at the diffs, I guess. There was also a bit of additional text about Sigfox that I added in with Juan Carlos today, or well, not when we do. Couple of days ago, and there was a minor tweak about the LoRa text, but otherwise it should be fine. I think that we may still be waiting on some references from Charlie's mail in his new text. So I'd say we have a look at it for a couple of days. Maybe we'll add a new version with a couple of references, but basically that's it. So next slide. Oh yeah, I have it. Sorry. Previous slide, sir. Am I kidding? So. Basically, yeah. So we now have a 06. So I give it a few days to sanity check it, and I guess when the Shepherd's doing the Shepherd write-up, that'll happen anyway. There's no other changes. I think just declare victory and shoot it off. So unless somebody has a thing to say, seems like that.
Perfect, Steven. Thank you so much. I mean, everybody, and special thanks for Charlie for the extra effort to make our dates. And so yes, Alex is the Shepherd. He will be writing the Shepherd write-up very soon, and Suresh will be pushing this to the ASG. And with this, next step in our agenda is the fragmentation. So. Yeah. Carlos, if you can please show up.
Oh, yeah.
Oops.
Okay, hello everyone. I'm going to present the fragmentation part of the CHIC document. So first of all, let's take a look at the status of the document. So since Chicago, the draft was updated several times. Revisions have been 03, 04, and 05. And specifically on the fragmentation part, we received 2 detailed reviews, one by Diego on version 03, and another one by Dominic on version 05. So thanks to both for the very helpful reviews. And also there's been a lot of discussion and input received on in working group interims, on the list, or also offline. So thanks to everyone who has made comments and helpful contributions. So on the current status, the last revision published is 05. Although there are a number of updates already prepared, which are ready on GitHub in the working version of the document. Those updates have been prompted by Dominique's review. And we could say that overall fragmentation is fairly stable. So let's have a quick summary of the main updates. Actually, since Chicago, the version presented there was 02. So first of all, we have that packet mode has been removed from the document. We found that there were a few things that were not well supported, a few issues there, and actually there were some solutions proposed. So we can still continue working in packet mode, however, that should happen on a different document. So as a result, in this current document, what we have is 3 fragment delivery reliability options. The first is no ACK, second is window mode ACK on error, and the third one is window mode ACK always. Then we have also added the possibility to support multiple window sizes. So imagine that, for example, a node needs to transmit a very large IPv6 datagram, which requires a large number of fragments to be carried. Then one option is to use a large window size in order to minimize as much as possible the acknowledgement overhead. However, maybe the same node may need to sometimes send a smaller packet that maybe just requires a few, say 2 or 3 fragments to be carried. So in that case, it may be good to have to use in that case a smaller window size, because then that leads to using a smaller bitmap. So this kind of optimization is now possible by means of having a special rule ID for each specific window size that's being used. Then we have also added the concept of a highest CFN in the window that can be lower than 2 to the n-2. This is equivalent to having a maximum window size which can be lower than 2 to the n-1. Recall that n is the size of the CFN expressed in bits, as you can see in the fragmentation header, which is shown on the slide. And this is useful, especially in scenarios where there may be constraints on the available space for the bitmap. So the idea here is to be able to tailor, to exploit the bitmap space as much as possible and tailor the window size to that available bitmap space. So for example, imagine there are only 24 bits for the bitmap, then we can use a window size of 24 fragments. That would mean highest CFN would be 23, n would be set to 5, and sender and receiver would be aware of this, so there would not be issues. So this is optimized compared with the previous approaches of the document, where, if you remember, we didn't have this flexibility. So the best option in terms of low overhead in the past would have been to set n to 4, have a maximum window size of 15, so there would be one acknowledgement every 15 fragments. So now we have this additional flexibility, and we can have one acknowledgement every 24 fragments. Okay, then we have also added 2 fragmentation header fields. One is the W bit. This is a 1-bit field which carries the same value for all fragments that correspond to the same window. This is necessary to avoid ambiguity at the receiver side, because losses can happen. So there might be situations where the receiver might not know clearly whether a fragment corresponds to the current window or maybe the previous one. And also, for the same reasons, the W bit has to also be included in the acknowledgement. Same reasons, but in the other direction. And on the other hand, the second field is the datagram tag, in short, D tag, which is actually optional. And if present, it carries the same value for all fragments that correspond to the same IPv6 datagram. So the purpose here is to allow interleaving fragmented IPv6 datagram transmissions. And if used, then the D tag field is also has to be also included in acknowledgements, so that the fragment sender knows what is being acknowledged, to which datagram the acknowledgement corresponds. We have also added timers. So in window mode Aconera, we have the timer called, the Aconera timer, which is started, it runs on the receiver side. It started when the receiver gets the first fragment of an IPv6 datagram, and then it is reset every time that the new fragment is received on the receiver. And if the timer expires, then it means that at least the last fragment of the window has been lost. So recall that in Aconera we have NAC-oriented behavior. So then the receiver would send an acknowledgement to report what has been received and not received. And the timer would be reset and restarted, and the receiver would wait for fragment retries. So in ACK-always, in window mode ACK-always, we have the ACK-always timer, where the fragment sender, after transmitting the last fragment of a window, will start this timer. And upon expiration of the timer, if the acknowledgement from the receiver hasn't been received by the fragment sender, then the sender will send again the last fragment that had been sent, and will restart again the timer. So we also have some parameters that control which is the maximum number of retransmission rounds that there will be. So in Aconera, there's one parameter which determines the maximum number of acknowledgements per window that a fragment receiver is going to send. This is the first parameter, as you can see. Then in ACK-always, there are 2 parameters. The first one is max ACK requests. The idea here is this is the maximum number of times that a request for a specific acknowledgement will be sent by a fragment sender. And there is max frag retries, which determines the maximum number of retransmissions for fragments that are reported to be lost in an acknowledgement. In addition, we have added the abort message, which is a special message which can be sent by a fragment sender or a fragment receiver in order to abort all ongoing fragmented IPv6 datagram transmissions. And this special message has also some corresponding special rule ID to signal it. And finally, we have added a particular section on downlink fragment transmission. So this is motivated by the fact that in some layer 2 technologies, sending a downlink data unit is only possible right after a previous uplink transmission. So if we want to send a downlink fragmented IPv6 datagram, then the receiver of the fragments may want to send an uplink message right after a downlink fragment is received in order to avoid potentially large transmission delays. So then, as I explained, the last version published is 0.5. However, there are a number of proposed updates already prepared on GitHub. And there are actually a number of updates. However, some of them are rather minor. So this is a summary of the main ones, possibly. So let's go through them. First one is important for terminology. We were using the term CFN, compressed fragment number. However, Dominic pointed out that this might be a little bit ambiguous because maybe a reader it couldn't be clear maybe for a reader whether what is compressed is the number or the fragment. So just to avoid this possible ambiguity, Dominic suggested to modify the term. So the proposed update is fragment compressed number. So unless there are objections, this would be like the new term used, the new acronym. Then the highest FCN in the window is actually a constant. So this was not so apparent in the previous version of the document. So now in the proposed updates, this will be more explicit. And also there will be a notation, a specific notation for this, which is proposed to be max win FCN. And also there is now an assumption that would be made more explicit also. This is for window mode Aconera, and it relates with the sender behavior. So the idea here would be to explicitly explain that an assumption is that the wait time for an acknowledgement in Aconera has to be actually smaller than the time required to transmit a complete window. So a sender would expect to receive an acknowledgement before the transmission of the next window of fragments. Otherwise, there would be problems with the behavior of the protocol. And this is something that needs to be carefully considered, especially taking into account the latency characteristics of the underlying layer 2 technology, among others. And finally, there's, from the discussion with Dominique, there is actually one outstanding question. He was suggesting that maybe we might want to define the use of max frag retries, this parameter, which is currently only defined for ACK always. The idea would be to consider whether this might be useful in Aconera also. So the reason why this is currently not yet considered in Aconera is that a fragment receiver will send an acknowledgement. By doing that, it will consume some resources, which may be expensive, and that is done with the expectation that then there will be fragment retries in response. However, Dominic pointed out that maybe this could also be used as an attack. So, for example, it might be possible to send this kind of ACK to some device and make it believe that it has to resend some fragments, and this might be a way to maybe deplete the battery of the attacked device. So then there might be different options on how to proceed with this. So there are these three questions, A, B, and C here. So first is, okay, should we then define use of max frag retries also in Aconera? Then, okay, if we define it for Aconera, should we explicitly say that maybe we should allow up to an infinite number of retries and maybe defer to future Shikobafu documents what has to be done here? Or is this something that should rather be handled at an implementation level and not really be explicitly specified here? So what do you think?
Pascal Tuber, individual contributor here. I would certainly want to see this discussion on the mailing list. I would like to see tickets from now on for things like that, because we are near completion and we need to track those things. And again, as an individual contributor, I don't think it hurts to have the variable and recommend it to be one. I certainly want to see this discussion in the security section. So saying, oh, there is an attack vector here, here is how it's mitigated, we recommend value 1 for that reason, etc.
Okay, thank you. Actually, that's everything for this presentation.
Charaton, fantastic work.
Sorry?
Charaton, excellent work. Thank you so much.
Thank you.
Yes. So just maybe a question for to the group. So who has read and reviewed some part of the fragmentation section of this document in any version? So quite a few people there. And so the 06 version will be coming out soon, or you already published it? No. On the mic?
Okay, this is Anna Minaburo. Then for version 6, we are waiting to finish the modification in chic part of Dominic.
Mm-hmm.
And then we are done for the document.
Mm-hmm.
So I don't know.
So that's it. And okay, so has any maybe this is the final question. Has anyone started actually implementing the full chic document? So we know that there are the compression part that have been already shown for the moment, and now with this updated version of the fragmentation, who has already started actually implementing this? So there are two implementations there, Diego and Tivilo. So this is one of the things that I would really like to see before we actually go into declare victory, is to have some at least some first version of code running, so that we are sure that we've, because by looking at the document and all the work in the presentation, for me it seems that we've solved all the big issues that are out there. There may be some minor things to fix, but the thing is working. And I just want to see that there is like, okay, code-wise, it's also good. And then I'm pretty happy with the result. So,
yes, it's having one implementation is often quite good because it's just the first level of standard track documents. Having like on 3 with Laurent, and so 3 of them, 1 of them open source. I think we are in a great shape on that regard. So, and with this, I will ask Laurent or Hannah, I don't know how you distributed the roles. So, like I said earlier, the presentations don't exactly match the documents, because the fragmentation is actually in the same document as the IP UDP compression, which is most of the work for the compression, and then the COAP piece is a separate document. But this slideware kind of covers the compression, whether it's IP or COAP. Whether the documents as their structure makes sense, or if you want to ship that differently, is still an open question. But the presentation at least don't match exactly the documents. So be prepared to see something from COAP, compression, as well as UDP.
Okay, hello, I'm Anna Minaburo. I will present the update of the chic compression part of the chic IP and UDP draft. I want to thank Diego and Carlos over reviews that have already updated in the document in version 5. We are working with Dominic for his updates and modifications. So thank you also. One of the most important things between Chicago version 3 and today version 5 is that we define a generic framework. Then we work a lot of things. We take out things of the co-op draft to the chic draft in order to create a chic compression framework. Then we also generate and take out from the version 3. We were explaining how to compress IPUDP headers in the middle of the framework. Then we take it out and we create a new section. We also enhance a little bit the description of the processing of how to make the compression. This is in the general stuff, how we order the work. In more technical things, we add in the match mapping compression decompression action. Normally it was defined as a list. Then as soon as we see in the implementation, we also accept to be an array. We have a very big discussion of padding, as Dominic mentioned. Before hackathon, we didn't know if we put it padding between the header compress and the data, or we put padding at the end of all the packet. So as Dominic said, the discussion result is that padding will be at the end and after data. We add a security section for the chic compression. And then more explicit things that have been changed. We have to add or copy the architecture part of the overview draft in order to make the reference, not to the informational document. So we add, it's a copy-paste of the architecture that had been already defined in the overview draft. As you can see, some modification is instead of naming the host or things like things, we put it as device. We don't make an acronym. We only reduce the name device as dev, because the device could be many things. We also changed the name of the network gateway. We add a W to make gateway in order to be more understandable. And in the application server, we didn't put application as an acronym. We do it also as a reduction of name, because it could be a server or an application, or then we leave it as a more open. What else we add? In order that we join the co-op part with the IPUDP, we need to add new fields in the rule. So we add the file ID, and it's a new column in the rule in order to name all the fields of the header. We add the position and the direction indicators, and we change the name of the compressor decompression function as compressor decompression action. So with this, we have the same description of the rule for any protocol. Another thing that has been discussed is for the LSB and the MSB matching operator, or LSB compression decompression action, how to send the length of the value. So the thing is that for co-op, a co-op define a maximum number of 1024 bytes. So we need to have very large numbers, but we give importance to the very little number. That's why we put 4 bits for the little numbers 0 to 14. And we have to define large number, but we don't think we are going to use them in CHIC or in LP1. So the question, as Dominic put it in this, it was, what about the value 0? Value 0, normally you don't send it. But because for example, in co-op, in URI-path on URI query, it doesn't exist. 0 is that it doesn't exist. But when you have an accept or content, 0 is value 0. Then you have a 0. So in order to go forward with the sheet compressor draft, we think that this must be specified in the co-op draft. At least that's a question. Do you agree with this, or do you want that this specification will be done in the sheet compression?
Pascal here. My feeling is that we'll still discover stuff we need to do in addition to this document. So either we hold this document forever, which is a bad idea, or we stop somewhere in what we described generically, and we still need to keep some room for new ways in the forthcoming documents. Meaning that, in my view, in order to ship this document, and it's clean, right? So why not ship it? We need to be open that the forthcoming document will define additional stuff, including this. So I'm perfectly happy to see it move pushed to co-op.
Okay.
Carsten Moorman, there are about 1 million ways of doing a variable length field. I'd love to have at least some rough idea of why this 1 or 3 or 7 byte thing, 1 or 3 or 7 nibble thing is the thing that actually makes sense. So at least a little bit of thinking about probabilities of certain values and so on may be useful. The other observation is if your code space includes length values as well as the absence of the field, then just use one of the values for the absence of the field. So you could use 0 for the absence, 1 for length 0, 2 for length 1, and so on. So that need not be a problem. Of course, you need to define how this mapping works, but that is indeed specific to, for instance, core.
Okay.
Can we have a ticket on this?
Yeah.
Okay. One remark about the length is that, in fact, when we put a 0 length for array path, it's because we can have a rule that contains, for example, 3 descriptions of the array path, but you receive a packet with only 2 array paths. So in that case, we can have a kind of negative compression. It means that we send 4 bits equal to 0 to say that the first array path doesn't exist. So it's to really to have more flexibility on rule selections. So it's not sending something that doesn't exist, but it's say in the rule we have 3 places and only 2 are used. So that's why we will send this 0 length. And the other remark is about documents. So the first document describes a way to send the thing on the radio, and then we have to interpret this thing. So in co-op, we have to specify that if you receive something in 0 length when it's accept or content, it means it's value 0. And if you receive it for URI path or URI query, it means that it doesn't exist.
But I'm talking, since the semantics are different, isn't it a different rule or something? I mean, should not the action say this value means present, not present, and for a different action, it means what you read in there is the actual value, like a 0. I'm really troubled that you have a confusion of semantics when you have a action that can tell you what the semantics are.
No, we don't have, because it's different from. It's different behavior for the nature of the option.
Yes, that's what the action is. Yes,
but
so
if
why
you
is there
look more
still
carefully
confusion?
at the option, we have no ambiguity. If we just say option, then they may have a big ambiguity. But if we say URI path or content, there is no ambiguity.
So this sort of question. So here, what you're talking about is some very advanced compression in co-op and stuff like this. So it's like something very we think could, or you think could be nice to have. So we don't know if this is going to be used. Probably, yeah. So what I suggest is that we don't block the document on this, like trying to solve some problem that might, or some minor issue that we might need to solve, and we just say, go, we'll solve it in co-op. Okay. So.
It's here in this document we define some rules, some way to send the information, and in co-op we will define a way to interpret this information and try to optimize it.
Yes, I certainly don't want to delay the document for something like that. But since we have a solution on the table, which was just proposed by Karsten, let's open a ticket. Because if we now know that there is a value 0 for empty, and then the value everything is -1, and 1 means 0, that's a perfect solution for the problem. We have time before the working group last call to just discuss that on the mailing list, and if it's better, then we ship it. If we don't find anything, but we know we can solve it in co-op, then we ship the document and we'll solve it in co-op.
Okay. Okay, that's it. Thanks. There are more questions? Thank you.
Well, then again, congratulations for the work. I've never seen such a tight schedule as we had this time, and having multiple implementation working in less than a year, and interworking, that's just huge.
Okay, so I continue with another document which is shipped for co-op. So the first one is defining the basic rule, and we apply it to IPv6 and UDP. But for co-op, as we have said in previous meeting, it's more complex because co-op is asymmetrical. You have variable fin length. You have a lot of things that are different from statical things from UDP and IPv6. So what's new? First, I apologize, but for the document, nothing. So in fact, the draft expired, and we have to issue a new value, but now a new version. But now we have things to do, especially with variable fin length, so it will be done soon. So why we have done nothing is because we move all the tools we need for co-op into the previous document, which give a very good way to do a lot of very flexible compression. So for example, for co-op, we put the matching list. So it's a way to reduce fields like code or type. You have, for example, for code, you have a lot of value, but maybe you will use in implementation, you will use only 3 or 4. So this way you can reduce the size of code or type by just sending an index. And this way you can reduce what you are sending. We have also the asymmetry. So we have the direction that we put in the main document. It can be useful in IPv6 for the up limit. But here is very useful also because, for example, in one way you will send a post, and the other way you will receive error message or an acknowledgement. And this way, if we separate both of them, we can have a better compression of the information. So we can also compress co-op message by reducing the size of some fixed length size, like message ID or token. And we can use MSB and LSB action to do that. So now we have something that works quite well. We begin to understand more and more how we can do very optimal compression of co-op. So yesterday, for example, we can compress co-op in 2 bytes. So that was something very, very good. So the things we have to do now is to describe very well these very powerful things that can lead to a negative compression. It means that something that doesn't exist leads to 4 bits sent on the wire, but can be more flexibility in rule selection. So we have to describe this in details to see how, to understand how it works. So what we have to do next? So maybe we will have to discuss with core people about how we can adapt co-op to LP1 environment. Because, for example, we can have sensor that will send information every day or every hours. And since now we are putting IP, a server cannot make the distinction between a sensor that sends every day and another one that sends every minute. So we will have problem with timeout. And especially in the server, we keep a list of the message ID not to process twice the same value. But if this list is maintained as it's saying in the standard 5 minutes, and we are sending every hour, so if we do a retransmission, then of course it will be lost, and we will process again the message. So we have to tell the server, this sensor has a periodicity of 1 hour, this sensor has a periodicity of 1 day, etc. And if we want a generic server, maybe a good way to do that is to have an option that gives the time square of what we are sending. And this will have an impact also in the compression, because if we know all these things, we can dimension the message ID field and have something that will be optimal on the radio. So that's some, for example, things we will have to do to adapt co-op for LP1. Okay, so that's
fantastic. And since we have experience and basically message terms, would it make sense to put examples or also recommendations in annex to help? Because first thing is people will read this document and they wonder, you always find that, right? How much can you compress with this thing? And I have every 6LoWPAN document paper I've read says, oh, 6LoWPAN compresses 2, and they give some numbers and they don't know where they find those numbers actually. It would be great that if you have some examples that you feel are kind of really representative, like temperature and pressure in this room, if you could show the exchange, the compression, the rules that you use for that particular case. It's important because you may actually find that several way of writing your rules may work. There is not a single way of writing them, but there might be recommendations about how to write them well. And there might be examples of work done well.
Okay, in this document we have already example, but we can put more example. And we also study, when we develop it, the way Comai is using co-op, and so we can also give some example about Comag, but we will have also to study other platforms that use co-op and see how we can compress it.
Actually, on this point, I would be. I think that one of the things we should actually make sure is that the whole system is working, right? And this last point, for example, with the timers, this is something that seems pretty important to me, because otherwise, it's we can have systems where it just doesn't work because of the time scale difference. So this is one point that seems very important, and I'm not sure if you have other things that you have identified that need to be fixed before we can, or need to be addressed before we can say, well, it's ready to be deployed, and with the time we'll get more and more and more feedback on what are the rules and how we can do this efficient compression.
Yeah,
so,
but do we have to do this on LP1 or in core? That's the question, because we cannot put everything on this document, because we will discover new needs for new option. And if we add a new option, it's not a problem on the SHIC mechanism, because it's very flexible, and we say, okay, now in the rule you have this option times 12, for example, and it works. So it will not influence the compression. It's more the behavior of co-op server that have to be more generic, take more diversity of source of clients. So that's the question.
Yeah. So I think that here one of the points is you're right. So if we're defining a new co-op option, then we know where this work should be done. So in core, then the question is, of course, Karsten, how are you feeling about this? And are we going to how do we define here and we specify, okay, we want to have this option, and then we move to core to actually do the work, or
Well, you're in luck. We have a working group meeting in 1.5 hours. So if you can maybe generate a little bit of slideware to motivate this, we can discuss it right there, I think. Well, we have experienced this kind of problem before. So in the constraint space, all the typical defaults for timers do shift. So for instance, we had to do something to DTLS to make it work in the constraint space. So this is not a new idea to anyone in the room, and I can imagine putting this information into an option may be a good way to inform a peer that is not necessarily on the very constrained network to understand what the other peer is experiencing.
Any question for Laurent? And thank you, Laurent. Thank you, Karsten. I mean, we really appreciate this interaction with core. So the next presentation will be Diego on the ICMP compression.
Well, good morning, everybody. I'm Diego Duhovne, and we have developed this draft with Tomás Lagos. Lagos is the editor of this draft. And there's also an implementation of this draft working, which is open source, which the link is on the last slide. So our idea is a new draft, this is the new contribution, and is to define a way to map ICMP-v6 compression, of course, and SCHC compression. And the thing is that we have done some extra work trying to reduce the number of bits used, just reducing the bits on the rule ID field, since we have some freedom to use it. Okay. So the fields the packets we are compressing are the echo request, the echo reply, route solicitation advertisement, and neighbor solicitation network advertisement. So the things we're missing still, and that we're working on, are redirect compression, and to analyze the rule performance. Yes, please.
Now, just to say about the reuse, reuse of whole ID field, you put a semantic on this field, or?
Yes, we have added information even on the field, on the ID field,
because it's something when we design chic, we don't put any semantic. We don't even know the length of the field.
Okay.
So it's very difficult to apply a semantic, because it will be chic over foo that tells you use this size or this size, but the generic document doesn't precise anything.
So I may understand it's not allowed to do that.
For my opinion, it's not a good idea.
Okay, but since there was a phrase on there was some freedom to reuse it. Okay, but let's discuss that.
Okay. So just a question, a follow-up on this. Is it clearly stated somewhere that we should not have any semantic on the rule ID?
I don't remember.
So I think I agree with this, and I think we should add this. So because with future documents, people, I think that there will be this natural way of, okay, well, what if we do this? It's like, no, this you can get something random here, and it should still work.
Okay, but we have done it in this version. Okay, there are 7 bits we have saved because of this. Anyway, you can keep a static value of the ID field, the rule ID field, and then push all these bits to the payload. It's okay.
Actually, thank you very much for actually identifying this, because I think it would have been not a very good thing to move on with, and then maybe a year later to find out that people are actually adding semantic. So that's actually a great thing.
Okay.
Thanks.
So for the time being, we are going to explain what the semantic is, but maybe after the definition of CHC, then we change that. Okay. So we separated we just named all the bits, just that here. Okay. And for each of the bits, we have given a number of values. Okay. So we separated which is the next header field. Okay. Of the next field is the UDP. So we have reserved for this. Okay. 128 addresses. And then we need to define if the address is linked local or if it's global, okay, which you are using within the ICMP field. And we have reserved 1 bit for the future use. Then the mapping continues with the type of message we are using there. Okay, so we have mapped the ones we have already done. Okay, and the redirect is not implemented yet, but it has already a code. Then if you have another bit that sends if a single packet is sent, okay, or after the packet we have some extra information. We can think about some link options and so on. So talking about the echo request and echo reply specifically, okay, then this was the generic header, okay, this one for the echo request and echo reply. Then we are only sending 32 bits. Therefore, the identifier for sequence, the checksum can be recalculated, okay, and the type on code we can be shared between the node and the gateway. So, well, this over the last one cannot be seen. Okay, is optionally the link layer option, which is the only part we are sending for the route to solicitation type packet there, and every other part of the packet is not sent, so we are just using 48 bits, which is just economic in terms of bits. Okay. For the term of route advertisement, the other packet, okay, we just again sending only the link layer option. That's which is the indispensable. The thing is fundamental to send here. Then on the neighbor solicitation, it becomes a little bit more complex because we need like this indispensable again to send it the link local, okay, and the global. Either if you're using one or the other, because we are trying to understand who's around, and if there's the same prefix all around the nodes, okay, there will be a link local, okay, just a small value, but if they're not, okay, we have signed a full IP value, then it will be a global one. And then the ocean link layer is again 48 bits. For the neighbor advertisement, sorry, the last packet, okay, then we have also use only the target address, which is 64,128. That's the only either one or the other, okay? And we have ignored the option length or link layer there because we are just advertising ourselves that we exist within the network. And that's it. So the thing is, the mapping is just mostly straightforward. Yes, Pascal.
Pascal Thubert here. So you've selected a number of messages, and basically you've used all the possible bits. So it means like the format is stuck to the messages you've chosen. And rule of thumb, I would have thought that the first message I would have encoded would not have been one of those three. I would have encoded ICMP error probably to be able to report any form of error. Okay. And since I mean, just me, right? Okay. And so I'm just concerned that maybe the next step should be probably that the mailing list discusses about which exactly ICMP messages we feel should be protected by this mechanism, and I think error could be one. Okay. Okay. You want the ticket for it? No, there's no ticket because there's not. Okay. Okay. So last thing, the available implementation is published over there in GitHub. If you have any questions, yes, you can write to Thomas or to me, okay, or both, if you want. Thank you.
So actually, this is thank you very much for this work, and this is a very good question because it is not in our charter today, and at some point we'll need to ask ourselves, is this a work that we are going to be interested in doing? So I know we'll be talking a little bit about this, but as well as while we are speaking about this, I would like to ask if you consider it to be a work which is interesting for us, and maybe Suresh, if you...
Yeah, so Suresh Krishnan, so if the current items are all done, we can have a re-chattering discussion, but I know you have some open points right now, but don't talk about adoption right now, but just, until we decide, what are the kind of things you want to work on, hold it down to then, so you have something on for today, so we can talk about it at that point. Okay, so kind of to have a better view of what are the things that are required and see how it fits in there. Okay.
Yeah, sure.
Later, I will present the discussion we have in the mailing list. So this point was very, very interesting for everybody. So, okay.
I would have just asked if people read the document and if there is an interest. No, of course, we are way too early for this, right?
Okay, and I guess Laurent will need you back on the microphone. Again.
Okay, so that's something that is very old. So it's a very old document that is when we started working on CHIC, so we issue this document. But now maybe it's time to think again to work on it. So when we design the rules, we don't, in the document, we don't say any way to implement it. So we have one way is to use JSON, but it's not very efficient. And another way will be to use Yang. And so this is an attempt to do that. So in the rule design, as Anna showed, we have different fields. So we have different rules. So it's a list of rules. And each rule, we have a list of fields. And we have some value that will be well known. For example, if I find It's here. For example, for the field, we can define some well-known value. Currently, in our implementation is text, but it can be also an identifier, a generic identifier that says this field is an IPv6 version field. This field is a co-op your array path or something like this. So we have this. So for the position, it's a number. Direction is 3 possible value, bidirectional, upstream, downstream. Target value can be anything. It can be a number, a string, an array. So we have everything we will find in a packet. Matching operator, currently we have defined 5 of them. But of course we can add other one, but these one are the one we think are the best now, right now to do the compression. And same thing for compression, decompression action. We have a list of action that we can apply for compressing or decompressing. So it means that it's, so as I say, we can use JSON way to represent it. But here, for example, this is a rule we use for the hackathon. It's about 2,500 bytes. So if we use some technology that sends only 100 message a day of 12 bytes, it will take 2 days to send this word. So it's not quite efficient in LP1 technologies. And of course, what we need also is to do partial updates of patch. It means that we may change, for example, a source port because a node will change its source port, or change a flow label because a node wants to specify a flow label, or all these things. So we need a way to signal it and not, of course, send everything on the radio. So that's why Young could be a good candidate for, first, because we can have a compact and unique representation for some of the fields of the rules. And also we can have compact representation of the exchange between the node, the device, and the compressor in the decompressor in the infrastructure. So, for example, as I say, we can have, for example, a network gateway or a compressor that will assign an IPv6 prefix to the device. So it's a kind of neighbor discovery, or a very small neighbor discovery, and say you have this prefix. So then checksum and all the things can be done on this value. And the device can assign or can tell the network, I am using this port number, I am using this destination address. A node may change the destination address because you put an update on the node. So we need all these things. And what can be done also is to have something compact, is that this rule can also be compressed using shake. So we have something kind of recursive. So we have to define that in Young. So in the first document, we made a rule. So this is about the same rules, but it updates with the new version of the rule as we announced. Shown.
Before you go into the detail,
Mr. Please state your name.
I'm Carsten. Hi. The JSON you showed at the start is kind of the truck. I mean, it's big and it doesn't fit through Italian streets and so on. And the Yang Sieber is maybe the car or the Mercedes Smart. But maybe what we actually need here is more like Vespa. So I'm sure this can be made to work with Yang. I'm not sure that we don't have needs for keeping this stuff compact that go beyond what we would do with a standard Yang solution. I'm not sure. I need to find out in more detail. But I think that doing something just using CoAP and CBOR payloads, maybe even the new CBOR pact mechanism that we talked about in the CBOR working group, and maybe the CBOR patch document that Peter and I have to finish at some point in time, that might be even more compact. So if compactness is a really important requirement here, I would probably go into that direction. If general cultural compatibility with other management actions is our overriding concern, then we should go with the Yang Komi kind of solution.
For two things. Yang, for me, is a formalism that leads at the end to an implementation using CBOR and
both cases would use CBOR, but
so the implementation by itself will not be that complex. What we have with Yang is a formalism that helps us to design this.
Yes, but if we use Yang, I think there is a certain expectation that we would use the Yang CBOR. Or do you want to do a second CBOR encoding?
Oh, it's Yang CBOR.
Yeah, and what I'm trying to say is we can go way beyond the level of compactness offered by that if we know exactly what we want to do. So Yang is kind of the general thing that works very well, and yes, you can transport a sofa in a Mercedes Smart if you have to, but maybe we need a Vespa.
So Alexander Perov. So yeah, these are like 3 points here that are really important, and this is why I think that Yang is the right tool to use. So the first thing is, as Laurent, that you said there, is that it actually provides the semantics, that it actually says, okay, I mean, JSON, this is just a representation, right? But you still need to know what co-op.code is and how, that IPv6.version, what it is. And right now you have it like in a text. So Yang is the formalism. It's the formal way that you describe, okay, there is a model. So there are these fields, and I expect here to, at that point, to have this type of value and so forth. Then you have, as Karsten said, you have the Yang to CBOR mapping that actually allows you to map this thing to CBOR, to something that is very, very efficient, right? And then you have the protocol bindings that come to COMI, so that you actually are using patch and fetch. So this is already in COMI. So I think that we should also look into the way these things will be implemented, deployed, and we don't want, I mean, this is like chair hat off, like this is really a personal opinion, that we want to have running code, and we want to have interoperability, and we want to have something very efficient, but in the same time we don't want to spend too much time designing some new protocol or some new thing that is made for this.
Yeah. Right. And another argument is that if we have different protocol, it means that we put a value somewhere to say this is this protocol or this protocol, so it takes place. We have to send something on VR. The more we have something generic, the more we can compress all the information on the radio.
If I can react from just a higher standpoint, we want to get into a position where the quick and dirty is actually harder to do than the right way. And that boils down to having to enabling the reuse of all what the community has built, including, yes, Yang and all the tools which rely on Yang. Same thing for all the tools which rely on IP to enable you to go from A to B, security, etc. Even if it looks like, oh, it's so much complexity, actually, at the end of the day, for the developer, because all those tools are there, doing the right thing is a lot less expensive to develop and test if we use all those common IT tools. And that's really why we are doing all this, right? So this view of what Laurent is proposing here goes in that exact same direction of enabling the clean way in an easy fashion for anybody so that they don't do the dark and dirty way. Any other comment? Thank you so much, Laurent. What kind of relationship did you get with the young doctors? Have you started working with them?
I have not been killed by a young doctor right now, so.
Well,
no, I don't show it. So of course we have to do a lot of work in young representation, and it's a concept that it's quite new for me. So we do an example. So I think there is one at the end. But we have to take advice and discuss more about and Yacht is a good place for this.
Fantastic. I'm confused that the value is still anything. Probably there is a tree of representations that the value is what it's supposed to be. But so okay, fantastic. Let us continue this work, please. And yes, there are a lot of helpful people at the IETF, at every IETF, which you could contact and work with. And with this, let's go to rechartering, and we have got some slides from Hannah about the discussions we've had so far, and then we'll have an open discussion. And we have about half an hour for the whole thing.
Okay, I will present the discussion we have a little bit in the mailing list for these new items to be worked in the working group. So the first one was the Icmp compression. Thanks to Diego to make the first version of draft. This item has a lot of input in the mailing list. There were more than 10 people that said that they agreed to work in this Icmp compression. Then we have also the SHIC over specific LP1 technologies. I think it's very important. There were no input about these items. If there are volunteers to work on this, the idea is to see in the different technologies how we can define the different variables of the SHIC compression in order to work the best in the LP1 technologies. Then we have another item is the security for the LP1s with the SHIC implementation or compression. Then there were no input there, neither. And the other idea was the rules ID management. The idea is, well, the rule ID is an abstract number, but do you want, or is there any input about reserving some rules ID in order to identify that this belongs to fragmentation, this belongs to format values, this belongs to Icmp, this is more co-op, or we'll leave it as a general value, and this will be specified in the compression of the specific protocol in order to identify that this rule is for this protocol, or it's better to define some numbers for some protocols. That was one of the questions. Yeah.
So, Chair Hadov, just a short question here about the rule ID management. Could it be also specified in the SHIC over foo document? So, for example, this technology specifies, okay, well, for us, rule ID number 1 is fragmented packet, or rule ID 2 is Icmp, blah, blah, blah. So,
yes.
Is this also a possibility then?
It's also a possibility.
If I can react to that, I'd rather separate the informational description of a particular technology, like the nice draft that we have today, with something which could become normative and could be very small, but which we say, oh, let's focus now on setting those parameters and let's make that a standard track RFC. So I would like to keep those two separate.
Okay. And the last point was the young data modeling for SHIC, as Lauren presented once. Okay. So if you have more inputs or comments, or if you want to be volunteer to make one of these documents,
Srigonda Valley. So there were a few proposals in the past, right, like ready resource management and gateway to the network server, standardizing the interfaces. So I did at least once or twice, in the previous IETFs, I presented those proposals, right? Again, just to list, one is radio resource management on the gateway, right? Defining the objects, right? Irrespective of the protocol, but identifying the radio elements, right? Information elements that need to be managed. That is one work item, right? That is from deployment point of view, that is an extremely important aspect, right? Let's say if I'm deploying LoRa, right, or some other access network, I should be able to get the ready resources, understand them, at least manage them. That's one point. Second point is, if you look at it, currently there's no standardized interface between the gateway and the network server. So if you change the network access technology, LoRa to Sigfox pretty much they have the same issue. Fundamentally, there's a sensor, there's an access point or a gateway, and then there's some aggregation function, onboarding element, right? So this in between, if you can standardize one interface and which we can support multiple radio technologies, I think that will be of immense use. Essentially, industry will really greatly benefit from an interoperability point of view. Even within LoRa, Alliance is also not defining that standard, right? So this is a great opportunity for IETF to standardize that. So those are my two, proposals.
I would really love the technologies on the mailing list or what to react on your proposals, in particular the latter one, because that request, I would like to see it coming from people who will actually will deploy those things. I mean, do they see the same thing as you do? I mean, I really appreciate your view, and I would like to see if to get more people joining in and say, yes, it's a good idea.
Right. And I'm not just saying this on the mic, but I also, to be fair, I presented those proposals twice. So
this group knows now. I would like to see the discussion on the mailing list and people, because we have the technologies are being represented in this group. So I'd like to have this discussion on the mailing list and see support for this idea coming in to the help.
Sure. Thanks.
Suresh Krishnan. So Sri, you proposed it, right? So do it again, right? At that time, the working group was not chartered to do it, so you need to start that process again to get this thing done. But there's two things I wanted to say. First thing is we need to figure out what form this is going to happen. So is it going to be a standard stack document or informational stuff on what somebody else does, right? So that's the first decision we need to make if you want to go down this path. If there is interest, right, are we going to just document the stuff that other people do? For the overview stuff, right? We decided we'll document what other people are doing, about other technologies. That's one thing. Second thing is we had a very good relationship with the other SDOs, right? Going, and I want to keep it that way. So we don't want to be stepping on the turf and doing things for them. Okay, so we need to have an understanding from the other SDOs what their plans are. So would they like to come here to the IETF and do the work, or do they want to do the things themselves, right? And that might lead to choosing, let's say X of the SDOs, some subset says yes and some subset says no. That might lead to picking a different set of technologies than the overview for doing this work, right? So that's also something we need to consider, because for example, Sigfox might decide I've done this, right? And they might just decide to put it here or not, right? And stuff like that. So I want to be very careful on how we do this relationship, because we're not having formal liaisons or anything most of the case, except IEEE. But I want to be a bit careful here, chartering work. But I'm willing to do it if there's a community. So she gets the ball rolling, and then we figure out there's people to do. Then I'll make sure that the other SDOs understand that we are interested in doing this work, and then I'll go from there. But I want these three kind of steps to happen before we get in that area, because that is very, very technology specific stuff. And as Sri says, there's stuff that's in common, but we need to figure out if we are walking into a party uninvited, so yeah. Thanks.
Yeah, thanks, Suresh. Only one comment is, if you look back on the cellular side, the GTP is what, we never managed to, push, mobile IPv6, because GTP was deployed already in the 2G stuff, right? So here we don't want LPWANs to go that route. At least IETF can do something here. That's
I mean, it's very important that you raise exactly what you said on the mailing list, and I will ask for people to react from the various technology. We have several vectors to actually show interest. Well, it's too late for the overview, but there is a gap analysis in the overview. And then there are the individual documents, and then there's the mailing list. I mean, there are multiple ways by which the individual technologies can actually support what you're saying, or say no, I don't know. I mean, we need to see, right? And now if we see a converging interest, I mean, that's exactly why we're here.
Thanks.
So
thanks.
Well,
so yeah,
we have more time for a chartering. We had that private discussion about the need for an architecture document. We've seen already that the drawing, which basically gives names because Sri was on the mic 2 seconds ago when he was talking about gateway and network servers, and actually we are trying to spread the words that to be generic and not point at a particular technology, we kind of have a generic name like the radio gateway and the network gateway to name those things, and it's kind of obvious for everybody what in technology blah this becomes, and that's the overview actually helps you do that. But at some point we talked about the need for an architecture document which would lay out how we see things, and just wonder if people in this room think it's useful. Raise your hand if you think we need an architecture document.
So, I mean, let's take this in a different way. No. I mean, let's say this in a different way. Today we have. So I would not address this like in the sense of okay, we have gateways, radio gateways, and so forth. I mean, that has been done. We have already some things out there. It's mostly in the fact that we are bringing like we have the compressor decompressor now. And we have the compression, and this thing is like it lives somewhere out there, and it must be surrounded in. I mean, we must construct something around it so that it is actually viable. Part of this, part of the things that we need to do is, for example, how we define the compression, how we express the compression context. So during the hackathon, there was this JSON format that was, like people around the table defined it, so they were able to interoperate. Right, but right now we need to go to we need to define an extensible mechanism to actually doing this. So Yang is one way to do it. There may be others. There may be the use of COMI and so forth and so forth. But there is maybe this need to actually define how all these things, and there'll be new things coming, how they will orchestrate, how they will work together. Because like we're building this, and maybe, I mean, I think that in order for systems to interoperate, we'll need at some point to have a document that describes, okay, a new device comes, sends this type of message, comes to the other, then, the compressor gets the context from this and there and there and there. So all the things that we've been doing for the moment, like hard-coded, to move this to a system that's actually working.
Much better expressed but that's exactly what. Thank you. If you could say what I'm going to say next, that would be useful.
So, I mean, because we had all these discussions before that, and I know that what we were talking about, so I just didn't want to do it. So, and it's like the whole system, how the whole system works. And I will ask the question, maybe, Juan Carlos, do you want to say something before I ask the question if there is interest of doing this work? Okay, so you need to say, okay, go ahead, Juan Carlos.
Yeah, Juan Carlos Oñiga, yes, I'd like to ask a question. So thanks, yes, I think that's a much better explanation. I wasn't sure if we were talking about network architecture, functional architecture, what that.
Big picture.
But
I was after a big picture, so we can position, if we are talking about chartering here. So there needs to be a map and say, oh, we want to cover this piece in the map. And so having we started that when we did the BOF work. We provide a very initial vision of what the big picture was. And we said, oh, we could be working here, we could be working here, we could be working, I don't know, how to position the compression state in the place where the compression or decompression will happen, because this thing must be agnostic to start with. It doesn't know which device will be placed in the network. So there's a number of functions that we know will probably care for. And if we have this map, then we could navigate it and say, let's charter this. And that's what I was after.
So then my question is, first of all, I do see value in this document, because indeed it's always hard to explain to people, our development the groups and so on, exactly how things work. So a document like that would be very useful. But right now we are still talking about Yang, ICMP, and rules, so fragmentation. So how do you foresee the timeline of this document compared to the work or where we are? So is this something that will come after we have already agreed on this Yang fragmentation and rule definition, or is it a moving target, or is it a live document that we will freeze at the end once we are happy with what we've done? Or
okay, so personally, I think that we should have it should go in somehow together. so that we have this, we discuss and we say, okay, well, there is this first super important piece that we have now, that is the shake compression mechanism, and now we need to make it a living thing. So in order for it to live, we need this, this, and this, and then we need a document that actually says, okay, these two work, or these things together, they work this way, right? So I would go with a pragmatic approach where we have like the description of how the things work, and maybe put some references to, okay, this thing could live as a function in this network element or this network element, but I would mostly focus on the protocol part of it, how they all interact. So develop them in parallel.
So not publishing the document before we finish those discussions.
Yes. So we had the similar question in 6-ish. So if we can take inspiration from that, we wrote an architecture from almost day one, which gave a big picture of where we thought we were going the day we built everything. And obviously, we had only half of the protocols or less than that were needed for this big picture. But we didn't know that whether we would build the big picture all the way. And this has been effectively a moving target. And we have been saying, oh, now we found a way to do this. It's going to be that protocol, for instance, the joint process that we are building. And some things will maybe never happen. But that gave us the map, the high level from some distance view of what we covered globally, and where we could be working and how those things interact with one another, etc. So people can figure out, oh, you're doing this building block, but that's where it will go in the world.
Okay.
So while you're still on the mic, actually, I would like to get back to this list of things that that we discussed and that people say, okay, that could be interesting to work. There's some interest. So you as Sigfox, as a technology provider, which one of these elements seem important to you, and things that we should be looking more for future work?
Well, the list is pretty comprehensive. I think we have already discussed this. I see value in most, if not all of them. ICMP definitely, SHIC over FU, sure. Security, I'm still puzzled about what exactly, because here it says everything, and I specified security for SHIC. And so I think we need to dig more into what exactly it is before I could say yes or no. The rules ID, I'm open to discussing whether it falls into SHIC over FU or it's an independent. And the Yang, for sure. I mean, we've been having this discussions on the Yang of things, and I think it's extremely valuable to open up. Plus, of course, this architecture or high-level description or functional description, etc. document.
Okay, so we can count on you for a SHIC over Sigfox document?
Yes.
Okay.
Okay. Anyone with some more on this list, or some items that we have not discussed? Any further thought? Okay, we'll continue on the mailing list certainly, and so we'll probably start threads on those items and try to get support echo from like Juan Carlos from other technologies, and then we'll go and propose rechartering items.
I wanted to ask, so this is a question to our AD, Suresh. So how do you see from here, given that we need to update some of the milestones, we're pretty much on target with a lot of them, but we need maybe co-op and these things. How do you feel we should address?
So I think, sorry, Krishnan. So I think we should work on the list, like trying to get this narrowed down before Singapore. So if everything is done before Singapore, we can actually do like the rechartering discussions completely on list and be rechartered for Singapore. But I'm not sure, like looking at the SHIC stuff, that we'll be done before Singapore, like shipping it out. Okay, so I'm glad to be surprised on that. But the way I see it is like be ready, like get the SHIC stuff done and ship it off. If there's any open issues, close them off in Singapore, spend most of the time for the rechartering discussion and get like, let's say like Sri's comments, Juan Carlos comments, like, like iterate on them on the list. Like don't spend meeting time like for doing that. And if there's anything open, because I'm sure there's something gonna come up that's gonna be, we're probably gonna hear from like the LoRa people, right? Like other IEEE folks, and I think there'll be work needed on the rechartering in the Singapore meeting. But I would like to get most of the work done before, like, you know, at least have a potential new charter, like what do you want to put it in, and like be ready for what comes up in the meeting. Okay, and so like I know Pascal, you can probably talk to the IEEE people to just socialize it, like at that time. I don't know if like
Bob is hiding behind this thing.
Okay, I see his watch now.
Yes. So
that's something we can like, you know, get started off on, and probably like Juan Carlos for the same thing, and maybe Alper or Jeff for the LoRa.
Exactly. I really wish to see those technologies showing up on the mailing list so we can have a better understanding of what they care.
And I think the 3GPP piece is like kind of missing, because like, you know, Antti is like not like doing this continuously, but I'll try to like dig up somebody like from 3GPP as well to take a look and comment, because if you miss like one, like then they're gonna do a different thing. So our idea of like, you know, doing like common thing doesn't really happen if we miss out like one of the major technologies we picked before. So as I said, like get started off on it, as long as it doesn't draw away resources from people who are writing the documents and reviewing the documents. If it doesn't take too many cycles, start it off now if you want.
Okay, and on this, so if we manage to ship when we ship the IP UDP SHIC, and maybe we delay a little bit the co-op SHIC because we need to go with the co-op option and all these kind of discussions. Is this, do you consider this as sufficient for, you know, if in November we have the IP UDP SHIC and say, okay, co-op, we know we have a milestone at the end of the year or something like that.
Sure, update the milestones, right, and I'll approve them. Like you guys have made like great progress, right? Like, and I know it was aggressive timelines. I know you're a little bit late, but I knew you would be a little bit late, right? Because the numbers are like crazy already when starting off, right? So I think it's pretty good. Like you made great progress. So just go ahead, and I think we can manage like, you know, one document pending from the previous charter. And we were chartered to do like one item, so like it ended up being like multiple kind of, but it's okay, right? Like, but we can have the discussion after. But I don't mind having the rechartering discussion now, like before Singapore or at Singapore.
Okay, thanks.
And with this, Bob, since I managed to grab your attention, I think you're going to be the next on the boiling plate. So, Bob, if you might. So I was lucky enough to be at the IEEE last week and attend the interest group LPWAN, which has met every day, and it was a really great sessions that we had. And then there were also a number of discussions about 15.4K, and then there is the general activity on Wi-Fi, etc. So there's a lot you can tell us about, Bob.
Thank you. Okay, got some slides on 15.12. I'll give you a little verbal on LPWA and the revision of 15.4, because we're endlessly doing revisions, sadly. Well, maybe that's good news. We had a number of goals in Berlin, opening report, of course, but the important stuff was we had a large number of presentations this particular go around, including detailed discussions on PDE, MMI, MPM, pass-through, et cetera, et cetera. So in terms of a general status update, we were looking at various format issues, you know, like where should L2R IE be inserted, and how should discovery be done with L2R, one of the major conclusions out that they are independent. We haven't arrived at a full disposition on that, but they don't have to be considered in combination, which I suppose is a good thing. And then in terms of where should L2R management be situated, we decided that should be in the application layer and in 8.15.12, the management functional block. And then we kind of looked over and tried to develop a list of generalized management functions. So as you can tell in 15.12 right now, we're really trying to get it fully organized. And I didn't include the the detailed functional diagram, but you can go find it on the IEEE document server. So in terms of data plane operation using 15.12, we kind of worked through an example based on 6LO. I won't go through this in ad nauseam detail, but this sort of describes the flow through the system, so we really could understand how the process worked and whether anything broke. And we think this is the general direction. So if anything spots anything haywire here, this would be or at least by September would be a good time to speak up. In terms of the management plane operation, we did discuss enabling configurations from the higher layer protocols, specifically NetConf, COMI, and IOCT control and need for remote configuration. We discussed how to identify profiles. So just this was a lot of generic stuff. And then an eye chart for those of you in the back of the room. We did have a number of accomplishments. I won't say we completed a lot of stuff, but we made a lot of progress on the ranging protocol modules, the whole L2R piece, the management protocol, as I indicated, protocol discrimination entity, the multiplex max interface, and then discussions on general architectures for 802.15.12. And I think that's the end. Continuing efforts are, as you might suspect, along all these lines, and we've identified forces. You'll see 2 blanks there, but I'm assuming, Pascal, you're in a couple of key figures, as you were in this last stuff for 6LoWPAN and 6TISH. That has not been an issue, so it's just, I don't know why Pat didn't put something in those blocks. And we're going to do a number of things in terms of looking at the functional block overview, just making sure that we understand everything about each of those blocks and how do they work, what functions are they, including all the stuff we've been doing on all those other elements. Like I say, if you look at the diagram, there's a rather huge number of functional blocks. Verbally now on LPWA, I think the biggest thing I really want to talk about there, I think most of you are aware that in 802.15 we've had an interest group, which translates to a BOF and IETF, looking at LPWA sort of as a generalized thing as it applies to 802, seeing if there are other things within 802 that might be brought to bear on the problem of low power wide area. So it's been a very generalized study. It's not intended to replace anything. It's looking for gaps. And I think the most interesting thing that came out of the Berlin meeting was we looked at, and I say we, I think Jorg, did the majority of work on this, the suitability of various aspects. So there were modulation schemes, forward error correction schemes, connectivity, network topologies, MAC schemes, and encryption schemes. He did a really nice piece of work there that may be of interest, I think, to people here. And what I'll do, since it's an extensive amount of work and no way can it be covered in 5 minutes, it's very easy to go to the IEEE doc server, which is Mentor, and it happens to be document 17-451. So, and it has all the links in it and all that kind of good stuff.
Can you please state it very slowly so we'll make, I would like this number to be captured in the minutes.
Okay, so document 17-451. This is an 802.15 document, so I should actually precede it with 15-17-451. So you're in the right place on Mentor. And if you're not a member of Mentor, you just get an IEEE web account, you go on to Mentor, you sign in, I authorize it, you get the document. So very easy to do. Lastly, just to very quickly.
Sorry, just a question. Is there any, like, what is the license under which, it's available for everyone, right?
Everyone.
Yeah. Can we
publicly available documents?
Can we just put it on our repository?
When you submit a document, you also, there's the front page of that says you forfeit any copyright stuff and stuff like that. So it's thoroughly open public document. You have to have nobody's permission.
I like this kind of copyright, right? But it's really good. So that we can directly put it in our document list.
Yeah.
So that's
and then lastly, we just finished 15.4-2015, but we already have 5 completed amendments. We have a roll up. So we're putting those together as a roll up, but 15.4 has had growing pains, and there's a number of things that still need to be cleaned up. We're trying to be much more methodical on this go around. And, I know there are things that might be helpful as far as 6-dish, 6-low, LPWA, and this would be the time. We're not fast tracking this. We're really trying to assemble something that really corrects or adds important things to 15.4. So this is just in the process of kicking off. So if you've got some stuff and you know somebody who's going, make sure you get those inputs in. Send emails to Pat Kinney, whatever. There's a number of mechanisms, and if you're curious about any of it, just send me an email at bhiley@IEEE.org, and I'll be happy to make it a part of the process. So that's it.
Clarifying question, Bob, if you don't mind.
Sure.
So far, 15.12 has considered 6LoWPAN because that was the only thing available. And now for the most extreme cases, this group is proposing SHIC. And I was wondering if it would help the developer and in which fashion to have also SHIC somewhere in this picture of 15.12. Does it make sense, or is it really an alien world? How should that be, or could that be integrated? And would that help?
Should be assembled in a presentation and made part of just the material that goes into the document. I said if there's enough agreement on it, this is not it doesn't take a lot of effort, but if there's enough agreement on it, then that'll move forward and could be included in the draft and stuff like that.
I can see the application user now using 15.12 and really 15.12 selecting how it's going to compress based on where it's going, and I see a lot of power in that. Sometimes the constraint is not really on the device. We can have this code in there. The constraint is on the medium, so you have to choose the tool well. But the application should not have to care too much as long as it has an idea of the bandwidth that it can use, right?
Yeah.
So.
Yeah, and it's also, by the way, why we separated 12 and 4. Just in terms of structure, it lets us really add things in 4 that are consistent with what's already in the marketplace, and we don't break stuff, and then 12 becomes a way of really adding to it a lot of things that were deliberately left out of the Mac to keep it lightweight.
Okay, so then a follow-up question on what you're saying, and thank you very much. That's really a great piece of information. Do you think that it could be possible to write up a draft that is something like
for contribution here?
Yeah, for contribution here
absolutely,
to have something like SHIC over 802.12, and then that could be because this is basically the way it's saying, okay, guys, if you want to use it, this is the profile.
Yeah, that would be very good. Yeah.
We'll
take that as an action.
Okay, that sounds really good.
Okay.
And I just wanted to say hi to Charlie. Thanks.
Hi, Charlie.
Charlie, fantastic. Thank you so much.
Thanks. Thanks, Bob.
I won't have the boot.
Thanks, Bob.
And with this, we can call for any other business. We are straight on time, perfectly on target. We need to because we are very constrained. Okay, so any other business? Anything you want to raise before we close the meeting? Then you just saved 5 minutes of your life. Thank you so much for being here. Use it wisely. Yeah. Okay, and if somebody did not sign the blue sheet, now is still time to do it. Blue sheets.